Hello everyone. In this video, I'll be doing a brief walkthrough as to how you can use the slide deck from today's lecture. Slide 2 contains a set of instructions. Please make sure to go through those. At the beginning of the slide deck, you have 3 review problems to go through. After that, you have a section called as refactoring conditionals. Recall that the term refactor refers to the fact that a programmer reorganizes the program in order to make the code more concise or more clear. You're going to go through a series of refactoring exercises as part of this slide deck. Let me walk you through refactor exercise 1. We have a function definition for OR2 function here, which includes 2 parameters of condition 1 and condition 2. The OR2 function is applying the Boolean logic operator of OR in between condition 1 and condition 2, and it is returning the Boolean value as the result from the function. You have 2 refactored versions which are marked as version A and version B. Then you have a question here which is asking which refactor is correct. Along with the question, you are provided a hint. The hint is suggesting you to try out a specific function call for OR2 function by passing false and true as arguments. Positional arguments line up with the corresponding parameters. So condition 1 is going to hold a value of false and condition 2 is going to hold a value of true. False or true is going to return a value of true from the OR2 function, correct? Let's go through refactor version B. Condition 1 is going to hold a value of false. Condition 2 is going to hold a value of true. Then you have an if condition which is of the form if condition 1 colon. Whenever you have an if condition of the form if variable name colon, then you need to do a couple of things about that. First, you need to verify whether that variable is holding a Boolean value. If that is the case, then the if condition is going to check if the Boolean value is set to true. If the variable does not hold a Boolean value, then Python is going to simply verify whether that particular variable has a defined value or not. Since our example uses a Boolean value of false inside the variable condition 1, this particular if here is going to evaluate to false, and you'll be running the block of code within the else, which is going to return false as the output from this function. Clearly, refactor version B is not the correct refactoring for the original OR2 function. Let's go through refactor version A. Condition 1 is going to hold a value of false. Condition 2 is going to hold a value of true. Then you're initializing a variable called RV with a Boolean value of false. RV just refers to return value. Then you're going through a couple of Boolean expressions. The first expression is checking if RV or condition 1. RV is holding a value of false. Condition 1 is holding a value of false. False or false is going to be false, correct? What are you doing with the result of this Boolean expression? You're reassigning that into the variable RV. The next Boolean expression is checking RV or condition 2. RV is still holding a value of false. Condition 2 is true. False or true is going to be true, correct? And finally, you're returning RV, which is going to return true as the output from the function. Refactor version A is the correct refactoring for the OR2 function. Let me walk you through a couple of Boolean expression examples for this refactor version A here. I'm going to draw a box beside the variable RV to keep track of its value. RV is initialized to false. The first expression that I want to go through is RV equal to RV or 2 equal to 1. 2 is not equal to 1. So this part of the expression is going to evaluate to false. False or false is simply going to be false, correct? The next Boolean expression that I want to go through is RV equal to RV or 3 greater than 1. 3 is greater than 1. so that part is going to evaluate to true. False or true is going to be true, correct? Let's go through one final Boolean expression here. I'm going to say RV equal to RV or 2 not equal to 2. 2 is equal to 2. So this part is going to evaluate to false. But true or false is going to remain to be true, correct? The lesson here for you to learn is that whenever you have a series of Boolean expressions that are separated by ORs, as soon as you find one Boolean expression which evaluates to true, then the result of the entire expression is always going to remain to be true, correct? So the refactor version for an OR operator that is separating few Boolean expressions is going to be for you to initialize RV variable to false and to apply each of those Boolean expressions as individual ORs with the RV variable here. Why is this refactoring significant? Let's say that you have a program which has many Boolean expressions separated by ORs. If you include all of those within a single line, that particular line of code is going to be too complex and lengthy to read, correct? Instead, if you use the refactored equivalent version, your program is going to be more readable because you're splitting each OR application as part of a single line of code by giving the corresponding Boolean expression. Let me quickly walk you through AND equivalence. When you have a Boolean expression which contains multiple Boolean expressions separated by AND, then the equivalent of that would be for you to use a series of if conditions, applying the if for each of those individual Boolean expressions. Inside the innermost if block of code, you're going to return a value of true. So this particular conditional will return true if and only if all of the Boolean expressions here evaluated to true, correct? Even if one of the if conditions here fail, then you're going to return false, which is the expected behavior that you need to have when you have a series of Boolean expressions separated by an AND. I'll wrap up this video here. Please make sure to go through the rest of the refactor exercises along with the review problems on your own. That will be it for today's lecture.